Yeah, it's time. Let's find the second derivative in terms of x and y of an implicit function. This is a very common type of problem that's asked, especially in AB and BC Calc, but I would say even in your college calc courses. How do we do it? Well, recall that d2y over dx squared means find the second derivative. So don't be scared off by that notation. Simply, we find the first derivative, solving for dy dx, and then find the second derivative. There's a little bit of a hitch in there where we have to write everything in terms of x and y, but it's a lot like finding any second derivative. Here we go. The derivative of all of this with respect to x. Well, the derivative of x squared is 2x, plus this will be 2y times dy dx. And the derivative of 16 with respect to x is 0. Nice. We're going to solve for dy dx, so we'll subtract over 2x, keep the dy dx on the left-hand side, of course. That's minus 2x on the right side. Then we divide by dy. So dy over dx equals minus 2x all over 2y. Not bad. The 2's cancel, and you're left with your first derivative is minus x over y. Okay. Now, from here, we're going to take another derivative with respect to x. So, all we do is treat this like a new function. That's it. So the second derivative, d2y dx squared, is equal to the derivative of that with respect to x. Quotient rule, right? So that'll be the bottom function times the derivative of minus x is just minus 1. It's with respect to x. So it's just minus 1, no chain rule. So bottom d top minus the top times the derivative of the bottom. Derivative of y with respect to x is dy dx. All over the bottom squared, y squared. Nice. We're getting there. We're almost done. It's not a bad problem. This will be a very short video. Y times negative 1 is minus y. Minus a minus x, in most places, is plus x. dy dx all over y squared. Okay. Now, the instructions said to rewrite your answer, or include your answer, give your answer, in terms of x and y, not in terms of x, y, and dy dx. So how do we deal with this? I'm going to move up here for some more room. We take care of the dy dx and say, wait a second, dy dx is minus x over y. So we take this and replace the dy dx with its equivalent form. So I get minus y plus x times dy dx is minus x over y. Not bad, not bad at all over y squared. Okay, now we're cooking. That simplifies to minus y, and this is going to be minus x squared over y, all over y squared. Now, I'm okay if you stop here, but a lot of teachers and some textbooks want you to keep going. So this is okay, but let me show you a neat algebra trick that some people use. A lot of people will then look at this and say, all right, we're not quite done yet. So they multiply the entire numerator by y to clear out this fraction, and the entire denominator by y. Or they do common denominators in the numerator. Y times minus y is minus y squared. Y times 1 over y, the y's divide out, leaving you with minus x squared all over y cubed. And you might be like, yeah, so what? Check this out. Factor out the minus 1. Who thinks to do this? You get x squared plus y squared. I'm just rewriting it with x in front. There's a reason why. All over y cubed. What's equal to x squared plus y squared? 16. So this is equal to minus 16 over y cubed. Some profs, some teachers want you to be able to do that. So let me show you how to do it. That's it. How to find the second derivative implicitly. Find the first derivative, find the second derivative, replace dy dx with everything in terms of x and y. Yo, it's time for the exercises. I'm psyched. I'll see you in those videos. Peace.